Okay, so I'm going to work through these problems on the study guide, and you can see the answers and see your work and hopefully understand it better, or at least see if you were doing it right. Okay, so this first one says a company is planning to manufacture wheelchairs. Fixed costs will be 500,000, and it will cost 400 to produce each wheelchair. Each wheelchair will be sold for $600. Write the cost function C of producing X wheelchairs. Okay, so for part A, how do you figure out the cost? Well, you take the fixed costs, and then you have to add in the cost per wheelchair. So fixed costs are 500,000 plus, and then how much does it cost to produce each wheelchair? $400. So it's 400 times X. X is the number of wheelchairs that you're manufacturing. Okay, write the revenue function. Okay, the revenue function is going to be R of X. And how do you earn revenue? Well, you sell the wheelchairs. And how much are you selling them for? $600. So it's 600X. Okay, when we want to, so part C. Determine the break-even point. Describe what this means. So the break-even point is when R of X equals C of X. It's when the revenue equals the cost. When those are equal, then you're not making money, but you're not losing money. You're breaking even. It's called the break-even point. So we want 600X to equal 500,000 plus 400X. Okay, that is a linear equation. Subtract the 400X. So you get 200X equals 500,000. And then we're going to divide by 200. And so we get X equals, all right, grab a calculator. And we get 2,500. Now, describe what that means. It means when we make, or the company makes, when we make and sell 2,500 wheelchairs. Remember, X is the number of wheelchairs. When we break even. Meaning we covered the costs. We didn't make a profit, but we broke even. Okay, well, you don't have to word it exactly like that, but all right, number 2, show that the ordered triple is a solution of the system. So we've been working on those in chapter 5. How do we show it's a system? Well, you're going to take the X value, the Y value, and the Z value, and you're going to do each equation. So there are 3 equations. Has to work in all 3 equations. So number 1. X plus 2y minus 3z equals 9. And so we're going to put in a -1 for x, 2 for y, and then -2 for z. We do the calculations following the order of operations. -1 plus 4 plus 6 equals 9. -1 plus, well, you can do it this way. -1 plus 10, which is -9. I'm sorry, positive 9. And so, yes, it worked. 9 equals 9. Yeah. You might be saying, well, why didn't you add the -1 and 4 first? You could have done it that way too. All right. Part 2. 2x minus y plus 2z equals -8. So we put in -1. We have to use the same point. Oops, there it is. -1 for x, 2 times -1, minus, and then we're putting in 2 for y. You can read it this way if that makes it more clear for you. Plus 2 times -2, and does that equal -8? All right, -2 minus 2 minus 4, does that equal -8? Well, -2 minus 2 is -4. -4 minus 4 is -8. Yes. Okay. We're expecting this to work because it says show, But yes, that says that it's a true statement, so the point works. And now for the third equation, we've got negative x plus 3y minus 4z equals 15. So we put in that point again. Now, a lot of times it's the negative signs that kind of mess us up, kind of trip us up. It's the opposite of x, or the opposite of negative 1. If you say it that way, it makes a little more sense. Plus 3 times 2 minus 4 times negative 2. And does that equal 15? So the opposite of negative 1 is 1, plus 3 times 2 is 6, and then that's going to be plus 8, and does that equal 15? 1 plus 6 is 7, 7 plus 8 is 15, so yeah. Right, and we have shown that the ordered triple is a solution of the system because we showed that it worked in all three equations.